All right, we're here with our student Jordan. And functions. You ready to go, Jordan?
Yep.
Okay, and we're really going to focus on linear functions here. And really, let's first talk about what a function looks like, a linear function. Our goal is to get something that looks like this. F of x equals mx plus b. Now, automatically you might be saying, I don't understand this f of x. Why did you say f of x? Well, this is just the way that we say this, and you'll understand in a few minutes here why we say it that way. But really, it's just the same thing as y equals mx plus b, which you're probably really used to. So what we want with y equals mx plus b, you probably remember that m is what? What does that refer to?
The slope.
The slope. Very good. Good memory. Okay, and b is what?
The y-intercept.
The y-intercept, okay? So the slope tells us how steeply a line is sloping, whether it's going up or down, and the y-intercept is where it's crossing the y-axis, right?
Right.
Okay, cool. So here we don't know what the y-intercept is because it's not called out. It looks like it's somewhere around -5, but we can't really be sure by just looking at the graph. So we're going to have to figure that out. And we can also figure out the slope from any 2 points. So let's remind ourselves how we do that. So the slope, which is m, is the change in y divided by the change in x. Okay, how much y is changing divided by how much x is changing between any 2 points. And we can calculate with that with 2 points by thinking of one point as x2, y2, and the other point as x1, y1. You can call the 2 points, this could be x1, y1, and this one x2, y2, or you could switch, it's going to come out the same. Okay, so here, let's go ahead and call this one x2, y2. Okay, and we're going to plug that in here, and this will be x1, y1. Let's go ahead and plug those numbers in here and make sure that I've done it correctly. So we're going to take -1, which is y2, minus -9, which is y1. Does that look right?
Yeah.
Okay, and then we're going to take 2 right here, which is x2, and we're going to subtract -2, which is x1. Does that make sense to you?
Mm-hmm.
Okay, good. Now let's just do some math. So -1, what's subtract a -9 is like adding 9, and subtracting -2 is like adding 2. So let's change that. Does that make sense right there? So this is like -1 plus 9 and 2 plus 2. Okay, what's -1 plus 9?
8.
Good. And what's 2 plus 2?
4.
Excellent. So we have 8/4. And what's 8 divided by 4?
2.
2. Perfect. Okay, so what's our slope?
2.
2. Okay. Whew. Glad we have that part done. Now, let's figure out this y-intercept here. And remember, what we're looking for is to use this equation here, f of x equals mx plus b. And we can use the slope that we just found and this equation and some of the points to figure out what b is. Okay, so it's like a little puzzle, and we know enough to use this here. Now, f of x is just the same thing as y. So let's use one of our points here. Let's use this point right here. What's the y value of this point?
-9.
Okay, good. So we're going to put -9 there, and then we're going to write equals. We're just rewriting this here, but we're going to put in some values that we know. Okay, what's our slope again?
2.
Okay, so equals 2. And then we can write the x value of that same point. What's the x value?
-2.
Good. -2. And then we don't know what the intercept is. We're going to leave that as plus b. Okay? So now let's go ahead and rewrite this. -9 equals, what's 2 times -2?
-4.
Good. So -4 plus b. Now we're going to add 4 to both sides. So we'll have, what will we have on the left side? What's -9 plus 4?
-5.
Good. So we'll have, I'll write it over here. -5 equals, and then we just have b over here. So we can turn that around so it looks a little nicer for us. So b equals -5. Okay? So now we have all the components of our f of x equals mx plus b. So let's go ahead and write that down here at the bottom. F of x equals, what's our slope?
2.
2x. And what's our y-intercept?
-5.
So what do I write here?
-5.
Good. That's a really good catch. So if we had said +5, we would have had the wrong the wrong y-intercept. And you know, when we looked on the graph, it looked like it was about -5, and there it is. Okay, so this is great. So we basically, from 2 points, we figured out how to write or construct a linear function, okay? Now, I know you're probably wondering, why don't I just write y equals 2x minus 5, right? That would be a lot easier, and this f of x stuff is kind of weird. Well, so why do we use function notation? Let me point out just a couple reasons why. So one reason that we write function notation is to make it easier to write math in general. So I went ahead and took our function here and I wrote it by our line over here. That what we can do is we can say, okay, let's write the different function values or the different values on this line. Well, if we say what is the function equal or the line equal when x equals -2, well, y is -9. We saw that right there, right?
Right.
Okay. What is the function or the line equal when x equals 2? Well, it equals -1. What is the function equal when x equals 0? Or what does y equal? -5. So those are all points that we figured out. But if we had y equals, how would we even write simple statements like this that tell us what the value of the function is at different x values? We wouldn't be able to. That's why we have this little f with this number in parentheses that says when the x value is -2, the function equals -9. Okay, that's the simplest, clearest way to write it. It saves you time. And that's why we have function notation, to make your life easier, believe it or not. It also helps us in another way to show two different lines on the same graph. So here we have one line, which is f of x. But what if we wanted to put another line on that graph? Let's go ahead and do that. Okay, and what if we were describing that line? If we have them both as y equals something, then we're going to get all confused. Are we talking about this line or are we talking about this line? Because y is this one thing. So we can call the first line, we can call that first function f of x. We can call the second line another letter, like g of x. Okay? And what that does is it allows us to say, put g of x over here, and we can identify it on the graph. And then when we're talking about one line versus the other, we can talk about f of x and g of x and not get confused between the two. And that's why you need all this crazy function notation. Eventually you'll get so used to it that you'll be like, wow, if I didn't have function notation, I would be getting confused all the time. And this is the easiest, most efficient way for me to do this math. Make sense?
Yeah.
Excellent job.